Hello, my name is Andres and this is activity 1 for microcontrollers. First thing we do is to configure our configuration pins. We set this as XT oscillator in order to use 4 megahertz crystal quartz or crystal oscillator. And then we set this default options. You can leave it as on, you can leave it as off. This would not affect the program on your PIC, on your microcontroller. The next thing we do is to declare a constant. For this activity, we're going to set a delay for each toggle of LEDs to be 500 milliseconds. And we define the ports that we're going to use. We define port RB5 to use on a green LED or blue LED, and the port RB1 to be the red LED. Actually, we're gonna change it here, blue LED. And as we change it there, we must change it in our main code. Okay, then we create a routine called init ports. This routine is going to initialize the port that we're going to be using. In this case, microcontroller PIC 16F84A has only port A and port B. And the port we're going to be using is port B, so we're going to declare it to be only RB5 and RB1 of our port to be declared as outputs. The rest would be used as an input or are not going to be used. Then we initialize the port B to be 0, and then we move to the main code. In the main code, we initialize the ports, and in our while routine, we call the variable, the define constant red LED to activate to print a 1, because in this it will turn on the red LED, and then it will turn off all. Will send a 0 or a low in the port for the blue LED, and then delay the milliseconds we declare to be 500 milliseconds, and then it changes. Now the red LED will be turned off, the blue LED will be turned on, and it would wait 500 milliseconds again. And this will be repeated continuously with no ending. Now we move on to the simulation. Here we have our crystal of 4 megahertz. And here we set it as 4 megahertz. We integrate or program our PIC. We make this range for a circuit to be, this will be sending a 1 to the master clear, and whenever we press this button, it will reset because it would send a 0, and it will reset our microcontroller. Will stop the toggling the LEDs. So let's see it work. As we can see, we are toggling the LEDs, LED red and blue LED. And if we press this button, it will send a 0 to master clear. And whenever this, as long as I keep pressing this button, as long as I hold it pressed, it will stop the routine. It will not do anything. If I release it, it will start the routine again. That's how it works in there. Well, now we're going to see it. That's how it works, and we are going to see implementing the hardware. Now we can see it implemented in the physical hardware. We see that the RB1 is connected to the LED red, and the RB5 is connected to the blue LED. So now if we press this button with this arrangement that we copied from the particular simulation, it stops the toggling of the LEDs. And if I release it, it starts again. I press it again, and if I release it again, it would start the toggling again. So we see that it works perfectly or as expected in the simulation.